if you are in the field of AGVs, you probably know the issue of 3D collision avoidance. 3D collision avoidance is really important because many damages are currently still happening inside of factories and manufacturing spaces and warehouses all over the world because the 3D collision avoidance capabilities are not sufficient. If damages occur because AGVs collide with the things in the warehouses and factories, the damages can account to over 100,000 euros or up to €1 million per year per factory. So the need to prevent this is definitely high. But why is this a topic to be solved? One of the most prominent systems being used right now is optical technology, 3D camera technology, sometimes LiDAR technology. But the problem with these technologies is that they still suffer from sunlight. They cannot detect floor-based objects reliably, or transparent objects have difficulties in being detected due to the physics of optical systems. This causes one object to not be seen in a reliable manner especially, and this is forklift forks. Everybody who understands how mixed operations work with manual forklifts and AGVs at the same time know about the issue of forklift forks in the manufacturing industry. So therefore, the 3D collision avoidance needs to not only see other objects like humans or other vehicles, but especially also pointy and also quite dangerous objects for the collision to be occurred. So therefore, the forklift fork detection is a very critical topic, and this is where still many systems in the market right now fail to do this in a reliable manner. And obviously, if those crashes occur, then you have a lot of damages, a lot of replacement costs. In the worst case, even the production can come to a halt, and this is to be avoided at all costs and therefore also limits the ROI of deployed AGVs if the 3D collision avoidance is not reliable and performant enough. So in this video, I just want to show you the scenario because typically what you have is an AGV running around the factory. There's a 2D LiDAR equipped. It doesn't see, for example, the forklift forked at the right position. And as you can see here, this is the result of it. Goods are falling over. There's probably damage to the AGV, potentially to the LiDARs, to the 2D LiDARs in place. There are several AGVs in line, not being able to continue moving. So therefore, you have a big problem, big mess that has to be solved. And this, is a pain the market wants to solve. So we are in this talk today to exactly talk about the solution to this problem, right? So how can this be prevented to not have this issue for the customers and also the OEMs of AGVs and AMRs anymore? Toposens is very happy to bring this new technology to the market. Toposens invented the world's first and only 3D ultrasonic collision avoidance sensor based on ultrasound, the Echo 1. The Echo 1 is a sensor that understands the environment like a bat, so we can use ultrasound to detect small objects, transparent objects in different kinds of weather conditions, and with that we bring a game changer to the market of 3D collision avoidance. So how does the solution look based on this very unique and novel technology? So basically, Toposens is providing to the AGV customer a 3D ultrasonic sensor solution plus the 3D collision avoidance software. So we are not only offering the 3D sensor that is generating the 3D data, but we are also delivering the 3D collision avoidance software, so the end user of the system has an easy time configuring the 3D collision zones as you already know it from 2D LiDAR systems, where you also configure the collision zones, but now not two-dimensional anymore, but now in 3D space. And with this unique solution as a combination, you enable your safe AGV operations and don't suffer all of these problems anymore, which I showed you on the last slides. The products Toposens is offering for the solution is on the one hand side the Echo 1 sensor, and on the other hand side the Toposens processing unit. In combination, they are enabling the AGV to get a simple output for the collision avoidance and to make the AGV safer. What are some of the key specifications of this technology? Because you obviously have an understanding of the maybe existing technologies like camera and LiDAR, but ultrasound behaves quite differently than the optical systems are doing. So one of the big benefits of ultrasonic technology is that you practically have no or only a very limited blind zone of a few centimeters. This enables you to also see objects at very close proximity. At the same time, we also have a range of around 3 meters, and 3 meters distance is fully sufficient for reliable collision avoidance in practically all application scenarios in the AGV field. And with this range, we also support an opening angle of 110 degrees horizontally with a high reliability of detecting the norm object, the 75 millimeter norm pole. At the same time, the ultrasonic sensor in the short distance, so the first 50 centimeters, is also supporting a 180 degrees opening angle, so it can cover the full front of the AGV or AMR just with one sensor. This is very unique, and again, the physics of ultrasonic systems behave a bit differently, so this is a great advantage, so you can be sure that the hull of the AGV or the goods the AGV is transporting are safe. On top of that, just as the bat is able to see very small objects in flight, the ultrasonic 3D sensor is able to see very small objects. And I was talking about the forklift forks before, which are very difficult to detect since they are small in size and only have a small reflectivity area. So our sensor is able to detect these objects with the highest reliability in the market, which has been tested by various of our customers. And this is one of the really unique points of our technology that we can avoid, especially these dangerous forklift fork collisions. So how does this look now in everyday operations? As you can see here, this is a typical scenario. So you have different types of vehicles. It can be mixed operations, so manual forklifts or autonomous forklifts. You have top loader type of vehicles, all moving around in the factory with different kinds of objects that need to be detected. As you can see here, if you look quite close, you would, for example, use two sensors for the top loader, one in the front and one in the back, and two sensors also for the larger vehicle, for the autonomous forklift. So it has full coverage in the front, or for the top loader in the front and in the back. So this is still currently a very normal situation, and now you can see in what situations the 3D collision avoidance starts making sense. Here's the forklift fork, which is very low to the ground, which is typically not detected by the 2D LiDAR. And in these situations, our system would tell the AGV a simple signal, okay, there's an object, you have to stop, don't continue moving to avoid the collision. This is, as you have seen in the video, maybe not the most dangerous situation, but you still want to avoid this collision. You will see why the short distance sensing, the missing blind zone of our technology, is of high importance. In warehouses, in manufacturing spaces, you're working in a very small and narrow environment and in various times. So you need to be able to be reliable in detecting, even if there's only a short amount of width to see the object, and as you have just seen here, even if the forklift is directly in front of the AGV, it can still detect it and does not crash into the system, and can detect it in different height positions as well. So this is what is solved, and this is how it's fluently running here, what your AGVs are able to perform with your customers if you use the Toposens 3D ultrasonic 3D collision avoidance technology. But now moving a bit into the technology. So how is the technology of Toposens actually working? What's the novelty of the system, and why will you not find any other systems out there in the market? So Toposens is coming from the algorithm side originally. So this is how we came up with the technology. We tried to figure out a new way of understanding 3D data from ultrasonic waves that a sensor is sending out. So we are basically copying the echolocation technique of a bat. The ultrasonic pulse our sensor is sending, typically with 20 frames per second, is reflected by the surrounding objects. Then inside our sensor, there's a small array of microphones listening to these reflections, and we then use signal processing to identify the time of flight of these echoes with a very high level of precision. And then those time of flight data points are processed by our 3D algorithms, and the sensor generates a 3D point cloud, so X, Y, and Z coordinates of all the received echoes. Then these echoes are transferred to our processing unit, which filters the data and outputs simple warning and stop signals to the AGV. So to understand how the sensor is really working inside the AGV, you can see here, for example, how the Echo 1 is mounted to the AGV. It enables you with a 3D multi-object detection, detecting complex objects, and easy to be integrated and mounted into the AGV. This is then connected to the Toposens processing unit. The Toposens processing unit is a key device because it acts as a gateway between the 3D ultrasonic sensor, so the Echo 1, and the AGV, typically the industrial PC or the PLC unit of the robot. The Toposens processing unit is, on the one hand side, translating the 3D data of the Echo 1 unit into simple stop and warn signals, so the AGV knows when to drive slower or to stop or can run at full speed. At the same time, it takes on the job of filtering the point cloud data, so you get very reliable data, so the availability of the AGV is guaranteed. And these are also the two outputs, basically, the TPU offers. On the one hand side, you have simple digital I/O output signals you can use to steer or maneuver the AGV. On the other hand side, you have the pre-filtered 3D data, which you can also use in a sensor fusion model if you want to combine the 3D ultrasonic sensor data with other sensors. We also looked at the usability of the system, so we want to have an easy application of the system into the robot. So on the one hand side, next to the Ethernet gateway for the pre-filtered point cloud and the digital I/Os for the collision avoidance signals, there is a graphical user interface which easily lets you pre-select different parameters, lets you adjust the sensor to the exact mounting position in your robot, and it lets you configure the 3D collision avoidance zones in a simple, moving the mouse over the collision zones and dragging it to the right position manner. So this gives you an easy possibility to integrate the 3D collision avoidance system consisting of the Echo 1 and the Toposens processing unit into your robot, and making it all a reliable system to integrate, and it's easy to set up the system and deploy the system also as a retrofit solution. Now you can see how we can configure the 3D collision zones, the warn zone and the stop zone. So if an object enters the warning zone, the vehicle drives slower. If the stop zone is activated, the vehicle comes to a halt. Now we can see some of the different situations where the system is important to be a 3D collision avoidance system. For example, as already mentioned, the forklift forks on the floor, but also elevated objects like the elevated pallet are seen even at a higher level, which would also not be detected by a classical 2D LiDAR. Also very small objects on the floor, like screws, which can scratch the floor of the manufacturing site or the warehouse, are detected, and also different colors are possible to be seen, for example, also transparent objects. So, but what kind of key features does our technology now bring? As I already mentioned, our system is able to detect forklift forks in a very high reliability. So we can detect forklift forks at different heights, also being close to the floor, which are typical situations which are difficult to distinguish for optical-based systems. Also, we can use one sensor to cover the full front of the AGV due to our wide opening angle in the close proximity and the super short range detection. As our system is also IP67 certified and we do not have issues with different lighting conditions, the system can be deployed in harsh environment and also in dense spaces where, for example, a radar-based technology can also not work properly. When we compare our technology with what you currently have in the market, we see, as you can see on the right-hand side, a unique performance of exceptional 3D collision avoidance performance. So we are able to detect with the highest level of reliability in 3D space, plus the best price value. And this is where we really differentiate us from all the other existing systems in the market, which sometimes have quite high prices or suffer from limited detection capabilities. So on the one hand side, it's really this detection performance of reliably being able to detect static, dynamic, and small objects. Then it's the immunity to all kinds of environmental conditions. We do not suffer from a big blind zone and have a wide field of view, so we are able to detect all objects in the close proximity. And compared to the, as you might know, the normal 1D ultrasonic sensor, our system is also able to generate 3D data, so not only the distance data to the nearest object. On top of that comes a competitive sales price, so that should make it an attractive offering for integrating this solution into the AGV to have the best-in-class 3D collision avoidance performance. So if you are building AGVs or have already deployed AGVs, so what are the benefits if you are using a 3D collision avoidance system of Toposens? So we bring the safety of robots to the next level. So therefore, with this increased safety, you can increase your sales because you can deliver better safety to the customers in the market, and the acceptance rate of AGVs becomes higher. At the same time, you can save money because there are no claims by the customers and the cost of our systems are lower than the 3D camera-based systems or LiDAR-based systems that are currently being offered. And with this great performance, we are also improving the customer satisfaction because no customer wants to have AGVs which are causing collisions at a frequent rate. So you want to have a high level of reliability in the deployed AGVs, and this is what Toposens helps solving. So overall, what we have as a big goal as a company with this technology to make AGVs safer and more reliable than ever before. So Toposens, as already mentioned, is currently offering the Echo 1 system plus the Toposens processing unit to deliver you the 3D collision avoidance functionality. These systems are already released to market, and in the middle of the year, so in July, we will be deploying our mass market solution. The LogiMart will be our launch event, so as the first parties, you will be able to see the mass market version in place. You will be able to see the demonstration and can convince yourself of the exceptional performance of our system. If you're also interested in evaluating the technology in more depth, then we are also offering proof of concept and pilot projects where we integrate the technology and showcase what kind of benefit 3D ultrasonic collision avoidance brings to your AGVs and the customers. To round this up, a short overview, who is actually Toposens? Toposens is a Munich-based company, now over 7 years old. We are over 30 people, very engineering driven, building this great technology. We invested many hours of R&D and filed a bunch of patents already, and now bringing this technology to the market after several pilot and trial runs over the past years. The company is already funded by several international investors like Plug and Play or Unternehmertum. So there are already big investors backing the company on the road to success. We also were able to secure great partnerships with companies like Infineon, which are providing the microphones for Toposens, or with NVIDIA, who is a great partner on the processing side. So I hope all of this explanation of the technology and how the Toposens technology supports making safer AGVs has gotten your attention.